right. So those of you who haven't seen me, I'm Jussi, and I'm an sorry, wrong place. I guess quite many of you have heard about k3s. Anybody haven't heard about it at all? Couple of hands, okay. So yeah, so this is actually based on my sort of, I had some free time at my hands during during January, so I played around with k3s a bit. So this is purely based on my sort of just having fun with it and nothing official or anything. So so I'll show a couple of slides that what K3 really is and what it means, and maybe some ideas why you might care or should care. Should you care? I don't know. It's up to you. And it's 5 less than 8, so it has to be smaller, simpler, maybe. Let's see. So yeah, K3s is really a sort of a distribution of Kubernetes. So it's an distribution in a sense that it's really conforms to the certification tests and everything. So what you get with K3s is still k8s, sort of, at least. What it essentially means that you as an end user deploying your application, you probably won't see the difference. So it's still full-blown Kubernetes in a sense that it has the same API, it has all the same controls and everything. There's some bits and pieces modified underneath the sort of hood. And the main thing is that it's much more lightweight than a normal Kubernetes. I'll go into the details in a couple of slides. And maybe even the most important thing, as it's built as a more lightweight version of Kubernetes with some opinionated choices, it actually might have lower cognitive load for you. Basically meaning that it's much simpler to operate. And being simpler, more lightweight, it has a lot of great use cases like edge, of course. If you think about the edge and the sort of people going towards the like true edge, running computing on a light pole on the street, you won't want to run a full-blown Kubernetes with etcd and everything on a light pole. So and for me, one of the really sort of interesting use cases is like test environments. So say you run for your application, you want to run some integration tests. You might want to spin up a cluster to deploy everything into the cluster and run some integration and end-to-end test cases. So to boot up those clusters easily and quickly during the tests would be one nice use case for K3s. That's at least one of the cases I'm planning to use it for. Let's see how it goes. But essentially, because it's certified Kubernetes, so you can use it for anything. There's no limit on the where you can use it. But of course, as with the service mesh, you first have to figure out that you actually need Kubernetes. So. All right. So I actually borrowed this image from the k3s IO website, which has all the official documentation and everything. So, and by the way, the k3s stuff is actually coming from Rancher, but it's full open source Apache 2 license, so there's no Rancher proprietary licensing or anything. So, and the mastermind, as with any Rancher stuff, is of course Darren Shepherd. He's the mastermind behind the k3s. So from architecture point of view, it's pretty much standard Kubernetes. You have your API server, you have your schedulers, controller managers, and whatnot. on the worker nodes you have kubelets and everything. No big difference there. But if you actually look at the picture, so there's this boundary being drawn like a process. So one of the things that Darren actually started with was to bundle everything within a single process. Rather than running everything like in standard Kubernetes where you run it, on the master nodes you have many different containers running. One container for the API server, one container for the scheduler, one for the controller managers and whatnot. So in K3s everything is actually a single process. And that part only, it already saves you like a few hundred megs of memory use, just by bundling everything into a single binary and a process. And the same goes for the agent, the worker side. So all the kubelets, Flannel providing the CNI, the networking capabilities, everything's bundled in the same process. Again, shaving sort of unnecessary overhead. And I guess this is what makes it highly opinionated, because, well, you can't really go and change Flannel because it's baked into the process itself. On the worker nodes, the containers, the pods are running with containerd. I'm thinking, can you actually even swap? I don't think you can even actually swap it out, so it's sort of not really baked into the same process, but sort of highly coupled in a sense, at least, as far as I remember. I'm not 100% sure, but doesn't really matter. From architectural point of view, one of the super cool things that's part of K3s is also these tunnel proxy components. So in a normal world of Kubernetes, both the kubelet and the API server, they talk actually back and forth. So you have to have pretty much connectivity on both directions. And now when you think about use cases like Edge, when you have some workloads running on the light pole on the street, you probably don't want to have a sort of open API on a light pole somewhere that the API server from some random place in internet can actually call to. So what they came up with is this sort of a tunnel proxy component. So basically when the worker node boots up and calls home the first time, the proxy component actually opens up a connection to the API side. And that tunnel is used as a bidirectional communication now. So now the worker node in a light pole can actually sort of punch open a tunnel to the master node, and that is used bidirectionally now. So that's actually super cool. So you can basically run your worker nodes anywhere. I can run my master basically on Amazon and the workers on my Mac, for example. That's super nice. Another things that are sort of shaved off on K3s is quite a bit of the sort of third-party storage drivers. You know that Kubernetes, it supports like 20, 30 different storage drivers out of box. People don't really use those. And we're anyway shifting towards using CSI as the storage interface. So basically shaving off that. I think Darren mentioned the line of code number somewhere, but it was a huge number of line of codes that they just delete. And same goes for the third-party cloud providers, because Kubernetes still has baked-in support for Amazon, Google, Azure, and something else, OpenStack and whatnot. And most people don't really use those. And again, we're sort of going to a direction where these cloud provider configurations and plugins are actually sort of external and not really baked into Kubernetes binaries itself. But well, we've been doing this in Kubernetes for the past few years already, and still we're not ready. So I don't know when it's actually going to happen, but let's see. Maybe technical point of view, the biggest change is actually changing the data store. So standard Kubernetes k8s uses etcd as you know, which is, how would I put it nicely? Not so nice, always. It's super complex. Of course, it has to have, like, it's a distributed, highly available data store with strong consistencies and everything. So it's not a simple problem to solve. So, but especially if something goes wrong, etcd is a pain in the ass to fix. So by default, K3s uses a SQLite, which is like single file. That's pretty easy to take backups and everything. It can actually work with basically any SQL database. Yeah. So yeah, some of the sort of enhancements that compared to like standard Kubernetes, that the reverse tunnel, I actually praised it quite highly already. And then as sort of part of K3s, it's actually separate sort of a project, but sort of born with K3s is the project called k8s. That's the sort of etcd shim. So something that sits between the Kubernetes that of course expects to talk to etcd. So that's sort of hard-coded in the Kubernetes at the moment. So you put this sort of a k8s shim process in between, which then sort of translates the calls to etcd interface from Kubernetes and translates those to a SQL calls, more or less. So that's a separate thing now, and the k8s has backend implementation for SQLite, DQLite, PostgreSQL, MySQL, maybe something else, but at least those four. So you can now actually spin up an Amazon RDS and use that as a data store for your cluster, which is pretty nice. They've also made this all these binaries as sort of these multi-call busybox binaries, which basically includes everything that Kubernetes and every component needs to operate, like IP tables and whatnot. Which essentially means that you basically have to get single binary onto your server and you can do everything with it. You don't have to figure out that, okay, I need up to get the install IP tables, this and that and this and that, and wow, shit, I have wrong versions. And you always have right versions because it's a single binary. And this single binary can do everything, like bootstrapping the clusters and everything. So that's super nice. Is everybody else noticing that we are actually seeing a sort of a, not really a new anymore, but we're seeing a trend in cloud native world. We're building tools, specific tools for specific jobs now. Like Linkerd had specific tools to set it up and everything. We have EKSCTL, we have this and that. Nobody is using anymore these general purpose Ansibles and whatnot. We're building specific tools for specific purposes, just as a side note. Couple of other things. So, especially for these edge type of cases where you might even might not have an internet connectivity, there's a manifest and image auto deployment mechanism. So, on the master nodes, or basically any node on the cluster, you have special place like var lib branch or something, where you put the tarballs of your images and it sort of automatically imports those as usable on the containerd. And same goes for manifests, and not only pod manifests, but basically any Kubernetes manifests. So basically it runs like kubectl apply, whatever it finds on the local disk. So you can sort of pre-bake your products or whatnot with this, which is nice. And of course, they had to do their own cloud provider implementation to get the external IP address in place for the nodes. Flannel for CNI, network policy control supported out of box, baked with containerd and runc, of course, has all the CNI, CSI interface binaries in place. Ships by default with traffic for ingress controller, core DNS metric server, the usual things. And everything is baked for AMD 64 and ARM, like for Pis and stuff, which is nice. All right. And I'm trusting on working internet on my demo, of course. Yes. All right. So for the demo, I'm just spinning a couple of nodes up with Terraform on Hetzner in Helsinki. I'm super annoyed because Hetzner says that the data center location is Helsinki, but it's actually in Tuusula. Yeah. That always annoys me. Apply. Yeah. Hetzner is super nice for demos and everything because it's super fast to provision. Terraform is ready now. All right. So, to spin up the k3s cluster, I'm using a specific tool for that called k3s up, pronounced like ketchup. Ketchup is actually initiated by Alex Ellis, the guy behind OpenFOSS, serverless stuff, and a bunch of other cool things. It's just a little helper to get the correct binaries in place and configure stuff, and nothing super complex or anything. And now on the k3s ketchup terms, install means that I want to bootstrap the control plane. Just copy paste the IP address. It basically takes an SSH connection to the provided IP, runs a couple of scripts and downloads the single k3s binary itself and executes it, then like in a minute or so we'll actually have our control plane up and running. Yep. kubectl get node. Not ready. Not ready. What? Now it's ready. Yeah. So that's pretty fast, right? And then let's join the worker node into the cluster. k3s up join minus IP. So we have to give the IP address to which one we want to join into the cluster, plus to which cluster we want to join it in. Server IP. So basically it connects first to the server, the control plane server, takes a special token from the server and then uses that token and joins and whatnot. Voila, my cluster is up and running. Which is quite fast, like 2 minutes. Well, it's a cluster. But of course, one of the good things with k3s is, and sort of one of the best things, that it's still conformed Kubernetes. So I can do whatever I want. I can do with kubectl or normal Kubernetes. It's the same API. So I don't have any special demo applications or anything. I didn't want to.
So it doesn't fetch the images from Docker Hub. So you need to specific like build it and put it.
Of course, it can pull images from anywhere.
From anywhere.
Yeah.
Okay.
It's a container D is a standard container runtime implementation. So
automatically it takes them
from the disk.
Yeah.
Yeah, that's sort of a additional feature of K3s. Yeah.
Is this running any services as pods? I mean, any infrastructure services?
Some. Some, like metric server, core DNS traffic, which comes out of the box. Of course, you can go and disable traffic and everything if you want, but as you saw, I went just with the plain defaults, because defaults are good.
Jussi, is this kind of like a two nodes, or can you add another master, or is just?
I can't actually now add another master because I went with the defaults, and the default is to use the SQLite as the database. And SQLite is like a single node thing. But it does support DQLite out of the box, which has this Raft protocol sort of on top of SQLite thing. But of course you have to install the first node with the DQLite too. But definitely you could do it.
But kind of worker you can just add if you just
Yeah.
join kind of.
Yeah. So now if I would go to my worker account, no, I don't want to open the wars file because there's my secret token and we're live streaming, so I've done it a couple of times and it's not a good idea. Trust me. But yeah, K3s is super lightweight.
How new is this? I've never heard.
It's been around since last summer or so, I think.
It got released last KubeCon, but it has been around before that.
Yeah.
But they
Yeah.
announced it, or like in version 1.
Yeah, I think Darren worked on it mostly like in summertime and got announced in around last KubeCon, like officially. Of course, everybody knew about it already, but sort of. Yeah. One of the things that people have been asking, like from Darren on his talks and a lot on Twitter and everything. So now we're running the data store as a SQLite. So what about scalability? Can I scale this to 1,000 nodes? And Darren says that yes, and I trust him. He actually says that with the SQL database as a backend, it should scale even more than with etcd. I don't know, I haven't tried, but I trust him.
So you mean SQL as a SQLite with my one master node?
Yes.
Only.
I don't know, I trust him.
So like in that case, why is the recommendation to use it like for the testing and not like for a production use case? What prevents you from using it in production?
Nothing. As I mentioned, you can use it for whatever. It's like, as far as the sort of official documentation said, it is production quality, yes. But I mean, as you saw, I did everything by hand. So if you do a bit of scripting around that, you'll get the cluster bootstrap time to a minute. So that's a good thing for test cases. So when you start to run your actual tests, boot up a new cluster.
So how about like, for example, if the thing you were mentioning about the cloud provider things that it's like stripped off and so on, like you think about like virtual kubernetes and the implementation of it, like these virtual nodes and that kind of for auto scaling. So all that needs to be done by yourself in that case.
Yeah.
But they still support like virtual kubernetes kind of.
Yeah, I guess it should. It should. And yeah, of course, you still can use these cloud providers. You just have to provision those components yourself because they are not baked in now into the API server and whatnot. But I saw some discussion on the k3s issues that they might have to take some of those back in, but I don't know. I haven't been following that closely.
So it also has the Helm, I guess, by default.
Yes, yes. And actually, for the Helm, just kick me out when I'm too much overtime. So for the Helm part, actually they did a sort of Helm controller and a CRD type. So you can actually now, if you want to install a Helm chart, you actually describe what you want to install in a CRD resource, just push that on the API. There's this controller component running which applies everything, which is kind of nice. Plus, yes.
Yeah. How much memory do you need on the worker nodes?
So these are the smallest ones that I get from Hetzner, and they are like 1 CPU and 1 gigabyte of RAM.
Can you do it with less?
Yes.
It runs
Yes.
in Raspberry Pi.
Yes. So I think by default it takes like 100, 200 megs.
Okay.
Like versus k8s takes like 100, 200 per process.
Yeah, exactly.
So how do you see, is this kind of going to kick up Minikube kind of, because that's
Probably.
what we use as testing kind of,
Probably.
this looks much.
And there's actually even K3D. Have you guys ever heard about kind? Kubernetes in Docker. So you can actually run the control plane and sort of virtual nodes on Docker containers. So K3D is like K3s on Docker, local Docker. Yeah. Inception, how deep you can get. Yeah.
Would it then make sense to, for example, run this in Linux containers and have like one container be master one and then few containers be nodes, and then you can see what happens if you kill off a few nodes and see?
Yeah, that's exactly what sort of the K3D does.
Okay.
Yep.
But it aims at Docker containers, not Linux containers.
Oh, yeah. But I guess it wouldn't be a big thing to, I mean, conceptually it's pretty much the same. Right.
How do you expose the load balancer in it? I think you mentioned it, but what is the IP address that is exposed, and does it expose every time a new IP? So when you have a service load balancer, what does it expose?
Service load oh yeah, you mean a service type of load balancer, yeah. So K3s has actually baked in concept for load balancers, and then it actually implements load balancer type services as sort of node ports. So it has this sort of baked in Clipper component.
So how do you hit your cluster from outside? Like,
You have to hit through the node port.
so you need the node IP addresses. So
Yeah.
it's, okay. So it's
Yeah.
a standard problem like we have on-prem.
Yeah.
You
Yeah.
really don't have any load
Yes.
balancers. Okay.
Yes. But of course I could go and install Metal LB or something, and which, as I said, it's still a standard Kubernetes, so you can use whatever solution works. But much more lightweight and simpler. Right. I think I'm out of time.
One maybe comment, like what you were saying regarding like this combining everything as one module, and there is a trend going towards it. Like there is, looks like trend for migration from the microservices towards some kind of like monoliths nowadays, like what Istio did as well. So is this like kind of like bundling things together and like in a way not giving you possibility to change it?
No, not really. I think this is more about efficiency and getting things more lightweight.
Were there the same components in use from the beginning, or it has been updating and changing?
It's been the same stuff
from the beginning?
from the beginning. Yeah. As far as I know. Of course, I haven't been following the code base that much, but. All right. Thanks.